Okay, deep breath. This one looks impossible. 3 squares, areas 3, 5, and 7, all meeting at a single corner. And somehow, one perfect circle glides through their 3 outer tips. Normally, this is where I'd phone a friend for help, but not this time. This time, I want to crack it myself. I just have to look harder and think like a detective. The question is simple to ask. What is the area of that circle? No hints, just me, the picture, and every clue hiding inside it. Let's go. First, what do I actually know? 3 squares with areas 3, 5, and 7, and a square's area is just its side squared. So the sides must be the square roots, root 3, root 5, and root 7. Now, what do I want? The area of the circle, and that is pi times the radius squared, so I don't really need the whole circle. I just need one number, r squared. Find r squared, and the puzzle is solved. So the whole mystery shrinks down to this. Somewhere inside these 3 little squares, the radius of that circle is hiding. Time to go find it. Here's my first move. That corner where all 3 squares meet, I'll call it O and pin it to the origin. Then I'll name the 3 outer tips, A on the 3 square, B on the 5, and C on the 7. Now, how far is each tip from O? To reach a tip, I cross a square along its diagonal. And a diagonal cuts the square into 2 right triangles. So by Pythagoras, the diagonal squared is side squared plus side squared, which is simply twice the area. So the squared distances come out clean. OA squared is 2 times 3, that's 6. OB squared is 2 times 5, 10. And OC squared is 2 times 7, 14. 3 tidy numbers. Now I stare, and a secret surfaces. Look at tips A and C. A points out at 45 degrees. C points at 225, exactly the opposite direction. Which means A, O, and C all sit on one straight line. The angle AOC is a perfect straight angle, 180 degrees. 2 of my 3 points are secretly in a row, threaded right through O. And tip B, it points at 135 degrees, square on, a right angle to that line. So OB stands perfectly perpendicular to the line AC, remember that. Let me clear the clutter. Fade the squares away. From here on I only need the 4 players, O, A, B, and C, and the circle through A, B, and C. And now the move I love. I'll just tilt my head 45 degrees so the line AC lies perfectly flat and OB stands straight up. Exact same picture, just a friendlier angle to think in. Look how simple it became. Measured from O, A sits root 6 to the right, C sits root 14 to the left, and B stands root 10 straight up. 3 points resting on 2 clean axes. So the center of the circle, I'll call it O prime, is the same distance, R, from A, from B, and from C I've stretched the picture out a little, so we can see everything clearly. O prime sits directly above M, the midpoint of the chord CA, that vertical drop, from O prime down to M, I'll call the height H. Now look at this right triangle. O prime, M, A by Pythagoras, H squared plus MA squared equals R squared. And MA is exactly half of CA, so H squared plus half CA squared equals R squared. That's my target. So I need 2 lengths. Start with the half chord. Because M is the midpoint, CM equals MA measured from O, CM is root 14 minus X, and MA is X plus root 6. Where X is the little gap from M to O, set them equal, and X is root 14 minus root 6 over 2. That makes the half chord, MA, equal to root 6 plus root 14 over 2. And squared, that comes to 5 plus root 21. Now for the height H, and here's the neat trick. From O prime, I draw a line straight across, parallel to the base, until it meets the line OB at a point P. Look at the new triangle. B O prime, P, it has a right angle at P, its legs are O prime P, which equals X, and PB, which is root 10 minus H, and its hypotenuse is O prime B. Another radius, R, so Pythagoras again. R squared equals X squared plus root 10 minus H squared. Now I've got 2 expressions for R squared. I set them equal. The squared terms cancel, and solving for h gives h squared equals 23/5 minus root 21. And finally, r squared is half ca squared plus h squared 5 plus root 21 plus 23/5 minus root 21. The root 21 cancels, and r squared is a clean 48/5. But hold on, r squared was the whole prize. The area of the circle is simply pi times r squared, so I just multiply. The area is 48 pi/5, about 30.2, and I cracked it all by myself. No calling a friend, just me and the picture. And look what actually did the work. One hidden line through O, a little tilt of the head, and nothing fancier than the center is the same distance from every point. No chord tricks, no trig, just that. Here's what makes this so satisfying. Those three squares looked like a random jumble. But the instant I pinned O to the origin, a secret snapped into view, two of the tips lined up perfectly straight, right through O. That one hidden line, plus a 45-degree tilt, turned a scary circle into 3 points on two simple axes. And from there, the plainest idea in geometry, the center is equidistant, finished the job. No special theorems at all. And it was never really about 3, 5, and 7. Swap in any three areas, and the same hidden line appears, the same tilt works, the same clean answer falls out. That is the quiet magic of geometry. Before you go, a challenge with a real prize. Same setup, but new squares, areas 3, 4, and 5, with the 4 square sitting in the middle. What is the area of the circle now? Everything you need, you already have. Distance squared is twice the area. Two tips line up through O tilt so they lie flat. Then let the center be equidistant and solve. Drop your answer with a short explanation in the comments. The very first correct solution wins a $5 gift voucher. If one hidden line and a 45-degree tilt made you smile, hit like, subscribe, and I'll see you in the next one. Aha!